Welcome to lecture number 5 of chapter 4 series. Now in this video we are going to learn about molecularity of reaction. Now what is molecularity? So it is one of parameter to understand the overall reaction. In previous lecture we saw about order of reaction. That is also one of parameter to understand the overall reaction. This is second parameter, molecularity of reaction. Now the definition is like this: the number of reacting species, whether it is atom, ion or molecule, taking part in elementary reaction. It is called molecularity of reaction. Now here reaction species that reacting here, they must collide with each other in order to react with each other. Again, the reacting species, they must collide with each other in order to react with each other. Suppose two reactants are there, so their two reactants must be collide with each other. So the molecularity of that reaction will be 2. Now here one example is written. Here you can see NH4NO3 gives N2 plus 2H2O. Here only one reactant is here and also 1 mole of reactant is here, NH4NO3. So this one molecule will react with itself and give nitrogen gas and water. So molecularity of this reaction is 1 only. Only one molecule is reacting here. So molecularity is 1 only. And the reaction in which molecularity is 1, they are called unimolecular reaction. Again, reaction in which molecularity is 1, they are called unimolecular reaction. If molecularity is 2, then they are called dimolecular reaction. If molecularity is 2, then the reaction is called dimolecularity reaction. If molecularity is 3, then the reaction is called trimolecular reaction, and so on, di, tetra, penta, that suffix we are using here. Okay. Now here few more examples are given to you. You can see the first example, in that 2Hi gives H2 plus I2. Now here by reaction you can see that 2 molecules of Hi that are reacting. You can see this one is our first Hi molecule, this one is our second Hi molecule. They both will collide with each other to form H2 and I2. So by that you can say the molecularity is 2 here, and this reaction is called dimolecular reaction. Now the next example, in that you can see here 2NO plus O2 gives 2NO2. Now the reactant here are 2NO and O2. So total 3 molecules are here, 2 NO molecule and 1 O2 molecule. So all these 3 molecules will collide with each other at same time. They all will collide. So molecularity is 3 here, and the reaction is called trimolecular reaction. Now look at the third reaction. In that KClO3 plus 6FeSO4 plus 3H2SO4 gives KCl plus Fe2SO4 thrice plus 3H2O. Now here the reactant are this much: 1 KClO3 plus 6 FeSO4 plus 3H2SO4. So total will be 10. So one can say by observing the reaction that molecularity must be 10, but that's not the case. Why? Because like us during this time, molecules also maintain social distancing. They do not combine in such number. The maximum, in most cases, the maximum molecularity is 3. only 3 molecules can collide with each other in maximum cases, 99% cases. So molecularity in most cases that cannot be more than 3. So what about this reaction? So this reaction is not a single step reaction. It must be a multi-step reaction. Now for this type of reaction, they are called complex reactions, and for this type of reaction you have to write down the mechanism first, and in that you have to find out the slowest step. Again, you have to write down the mechanism first, the steps which are including in this reaction, you have to write down them, and from that you have to find out the slowest reaction. Suppose this one is occurring in 3 steps. Now from the 3 step, second step is the slowest step. Now the molecularity of that second step is the molecularity of overall reaction. So how we derive the molecularity of complex reaction? So we derive the mechanism first, then find out the slowest step, then third step is to find out the molecularity of that slowest step. That molecularity is the overall molecularity of the reaction. Okay. Now take another example. The reaction is like this. 2H2O2 plus I minus gives 2H2O plus O2. Now here I minus is catalyst. Now from the reaction only, you can say that the molecularity of reaction that must be 3, because 2H2O2 is here and 1 I minus molecule, ion. So total is the 3. So by the reaction only you can say that the molecularity is 3. But this reaction is also multi-step reaction. So molecularity is not 3 here. Look at the steps first. First step, that is H2O2 plus I minus gives H2O plus IO minus. Now this is a slow step reaction, a slow reaction. And second step, that is IO minus plus second molecule of H2O2 will react, gives H2O plus I minus plus O2. Now here, the second reaction is fast. So like I said it previously, that find out the slow step. So our first step is slow one. Now in that you can see that 2 molecules are reacting here. One is H2O2 and one is I minus. So molecularity here is 2. So here I am writing molecularity is equal to 2, and the reaction is called dimolecular reaction. Now this is slow step reaction, I told you, and this step is called rate determining step. Again, it is called rate determining step. By this step you can determine the rate of reaction also. So this step is called rate determining step. So again, for complex reaction, first you have to write down the mechanism. Second, you have to find out the slow step reaction, the slow step. And third, you have to find out the molecularity of that slow step. That molecularity will be overall molecularity of the reaction. Here's the difference between molecularity and order of reaction. So first point is the definition. For order of reaction, it is the sum of power based on concentration. Yesterday we learned order of reaction. In that we were adding x and y power. So it is the sum of power based on concentration. While in molecularity, the definition is number of species taking part in elementary reaction. That is the definition of molecularity. Now, second point, order of reaction, that is practically derived value. We learned that order of reaction cannot be derived theoretically. It is a practically derived value. While molecularity, that is theoretical value. Order of reaction, that can be 0, fraction value, whole number or negative value. Suppose 0, 1, 2, 3, 1 and half, 2 and half, minus 1, minus 2. That value can be order of reaction. But in case of molecularity, it is only positive whole number. It cannot be 0, negative or fraction. And the last point, fourth one, order of reaction, that is assigned for overall reaction. Only one order of reaction will be there for overall reaction. But in case of molecularity, we saw that for complex reaction, if the reaction is multi-step, then we are deriving the molecularity of each step. And finally, the slow step reaction molecularity, that is overall molecularity of reaction. So, for complex reaction, molecularity of each step will be different here. So, molecularity is assigned for each step involved in the reaction.